The FP will depend on the actual timber species you're using. You can't make it up, you have to actually find out what sort of timber you're using or work out what sort of timber you're going to use. And the AP, of course, is the area of bearing. Now, remember the beam was 6 meters this way, and it's resting on a beam that way. So, sorry, it's 45 millimeters that way, and the width of this beam we said was, what do you say, it was 50 mil. So the area is 45 times 50. Okay, it's the contact area between those two beams. 45 times 50 equals 2250, and so therefore our NDP is going to equal 0.9 times phi, or that was the phi. K1 is 0.94, K4 is 1, K6 is 1, K7 is 1, F-P is 19 times the area is 2250, and this is going to give it to us in newtons. Okay, 2250 times 19 times 0.94 times 0.9 is 36166 newtons, which is 36 kilonewtons. All right, that's our bearing capacity. NDP. You normally like to draw a box around it because we're going to need that later. And if we go back to our beam, we can remember that the beam, we need to find what's the force. So the N star is the bearing capacity of the beam. So that is, oops, if we have the 6 meter beam, we're talking about the force that ends up right there. So it's basically half the force on the beam. So N star equals 3 times whatever our load is. And remember our main load was 1.2 times dead plus 1.5 times snow, which was 2.22 kilonewtons. So 3 times 2.22 equals 9.6 kilonewtons. So basically under this load there's going to be 9.6 kilonewtons on either end, and so that's our N star. So N star is 9.6 and our NDP is 36, so it's absolutely no problem. So N star is less than NDP. Okay, so yep, this beam is fine in bearing basically, and that's often the case. Bearing is rarely a limiting factor, and if it is, there's normal things you can do about it just around the bearing without having to change the whole beam size. There we go, we've designed a beam. We could also do it for shear if we wanted to, but we won't this time.